Earth feels solid under your feet, like a giant rock that never changes. But under that rock is a moving machine, hot metal, slow rivers of stone, and a spinning heart made of iron. And today, that heart has a problem. What if Earth's core suddenly split into two separate parts? That sounds impossible because the core is not a cookie you can snap in half. It is a blazing ball of metal, deeper than any drill could ever reach. But in this story, it happens anyway. And once it happens, you do not just get a cool science fact, you get a planet that starts to act sick. To understand what happens to you on the surface, we have to go down, past the oceans, past the deepest mines, and straight toward the center of Earth. Earth has layers, like an onion. The crust is the thin skin you live on. Under it is the mantle, a thick layer of rock that is solid, but it flows very slowly. Then comes the core, the center of Earth. The core has two main parts. The outer core is liquid metal, mostly iron. The inner core is solid metal, also mostly iron. It is so hot it would melt anything you know, but it stays solid because the pressure is crushing. Here is the key detail. The liquid outer core moves and swirls as Earth spins. That moving metal acts like a giant generator. It creates Earth's magnetic field, the invisible shield that helps protect you from dangerous space particles. So the core is not just a hot ball, it helps keep your technology working and your atmosphere safer. Okay, now let's break it. In our scenario, the inner core cracks and separates into two huge iron chunks. They do not fly apart like rockets. They drift. But the change is sudden compared to Earth's normal pace. The outer core, the liquid layer, does not like this. Its flow pattern changes fast, like stirring soup and dropping in two giant rocks. Up on the surface, you do not hear a sound from the center of the planet, but you feel it. It starts like a long earthquake. Not one sharp shake, more like a deep rolling wave that keeps going. Lights swing, water ripples in cups, phones buzz with alerts. Somewhere a reporter says, "This is not a normal quake." Why? Because the whole planet is adjusting its balance. When Earth's mass shifts inside, Earth's rotation can change a little. The day might become slightly longer or shorter, maybe only milliseconds. You would not notice with your eyes. But satellites and GPS timing notice everything. And while you are still trying to process that, the next problem begins. The magnetic field depends on organized motion in the liquid outer core. When the core splits, that motion gets messy. The field might not vanish in 1 second, but it can weaken fast. It can wobble. It can form weird patches, strong in some places and weak in others. First, compasses become less reliable. Airplanes and ships still have many systems, but navigation gets trickier. Then satellites start taking more damage. With a weaker shield, more charged particles from the sun can reach Earth's upper atmosphere. That can mess with signals. You may see auroras in places that never see them. Beautiful lights over cities that usually have normal night skies. It looks magical, but it is also a warning. Radio can get noisy. GPS can glitch. During strong solar storms, power lines can pick up extra currents. Some parts of the grid could shut down, especially if they are not prepared. And now you are thinking, okay, this is bad, but at least the ground is still here. About that. Here's where it gets extra confusing. If the swirling metal is no longer flowing in one clean pattern, Earth's magnetic field might not have one clear north pole. It could form two strong regions. Or the north your compass wants could wander day by day. That means the idea of true north and magnetic north becomes a daily headache. Pilots and sailors already plan for magnetic drift, but this would be drift on fast forward. Even animals that use magnetism, like some birds and turtles, could get confused during migrations. And the sky itself would feel louder. Not with sound, but with electricity. During solar storms, you could see more lightning-like glow in the upper atmosphere. Airlines might reroute flights away from the poles to reduce radiation exposure. Most people on the ground would be fine, because the atmosphere still blocks a lot. But astronauts and high-flying planes would have a rougher time. So yes, you might get stunning auroras, but you might also get a week where your internet is slow, your GPS is wrong, and your power company asks everyone to conserve electricity. And that is phase one. The core split changes forces inside Earth. The mantle is already moving slowly, pushing plates and feeding volcanoes. Now the heat and pressure patterns shift. In the first days and weeks, earthquakes increase. Not just in one region, in many regions. Some are small, some are huge. Fault lines that were quiet for years wake up. Coastal cities worry about tsunamis. Mountain areas worry about landslides. Older buildings crack. Some bridges get closed. People start sleeping with shoes near the bed just in case they need to run. And volcanoes, those are the next chapter. Volcanoes are pressure valves for Earth's heat. They follow weak spots in the crust. When the deep heat flow changes, some areas melt more rock than before. More melt means more magma. More magma means more eruptions. At first, it looks normal. A volcano here, a plume there. Then you see unusual activity in places that rarely erupt. Ash can rise high and spread far. It can cancel flights and make air hard to breathe. If enough ash and gas stay in the sky, it can block some sunlight for months or even years. That can cool parts of the planet and hurt crops. Now, here's the bad news. Good news moments. Bad news. If you live near a volcano, you may have to leave fast. Good news. Most people live far from lava flows, so they can survive the lava part. But the climate part can still reach everyone. Okay, at this point, this story feels heavy. So let's do what we always do. Let's take a look inside. Alright, you are wearing an impossible heat-proof suit, because otherwise you would not last 1 second. You drop past the crust, then through the mantle, where rock moves like a slow river. Then you reach the outer core. It is liquid iron, swirling like a stormy sea. And there it is, the inner core. Except now it is not one piece. It is two. Two iron worlds, separated by a growing gap, spinning, pulling on the liquid around them, breaking the old rhythm. You can almost see the magnetic field up above flickering like a tired flashlight. Okay, tour over, back to reality. If the core stays split, Earth does not explode. Gravity still holds everything together. But Earth becomes a tougher place to run. The magnetic field could stay weaker for a long time, which means space weather becomes a bigger threat to technology. Satellites need more shielding, power grids need better protection, communication systems need backups. The quakes and eruptions might calm down after Earth finds a new balance, but that could take years. During that time, people move away from risky coasts and shaky fault zones. Some cities rebuild, some do not. Now, what would you do to survive? Rule 1. Do not treat this like a storm that ends in a week. This is a planet problem. It lasts. You would need clean water plans, food reserves, and ways to handle power outages. Communities that work together do better than people who try to do everything alone. If you are near the coast, you learn tsunami routes. If you are near faults, you learn how to make buildings safer. If you live in an old building, you do not ignore cracks. And yes, this is the part where I ask you to subscribe, because if Earth's core can split, you should probably stick around for the next strange scenario. Could this really happen? In real life, the core is under insane pressure, and it is not easy to split. Physics does not like it. So the good news is, this scenario is extremely unlikely. But thinking about it teaches you something important. Your normal day depends on a planet-sized engine you never see. A churning ocean of liquid metal that makes a shield in the sky. A thin crust that holds your whole life. So next time you watch the Northern Lights, or feel a small quake and move on, remember this. Earth is not a dead rock. It is a machine. And if its heart ever broke into two, you would feel it everywhere. But hey, at least you might get one last beautiful night sky, glowing with auroras over places that never had them before.